We've seen Pandas data frames with numbers and strings. Let's move on to datetimes. Pandas stores date and time information in datetime objects. The Pandas readCSV function can read strings into datetime objects. The parseDates=true option helps transform dates and times in ISO 8601 format from specified columns into datetime objects. The ISO 8601 format reads like this. readCSV can also flexibly read from many date and time formats. As an example, consider some sales data from a company that sells hardware, software, and service products. This CSV file contains sales records from February 2015. Here are the first 5 rows. We can see that the date columns contain datetime information in ISO 8601 format. Since we know that the CSV file contains at least one column of datetimes, we can tell readCSV to parse all compatible columns as datetime objects with the parseDates=true option. Further, we're going to use the date column as the index. Later, we'll see that datetime indexes are very useful for data exploration. Here are the first 5 rows of the sales data frame. We can see the date column in the index. Let's look at the output of sales.info. We can see from sales.info that we have a datetime index that runs from the morning of February 2nd to the morning of February 26th. Remember, the .log accessor can be used to select data by row and by column. With datetimes in the index, we can use very sophisticated selections. For example, we can select the company that made a purchase on February 19th at 11 a.m. by selecting the full datetime string and the company column name. When using datetime on the index, Pandas provides convenient ways to select multiple rows. Let's try selecting February 5th. Here, we have 2 rows for the 2 sales events that occurred on February 5th. Notice that we did not specify a column name, so all of the columns were returned. This is called partial string selection, and Pandas supports this in a number of different ways. These are a few alternative formats to select February 5th, 2015. Pandas also allows partial selections for entire months or entire years. Here's the whole month of February 2015. Lastly, we can slice between partial datetime strings by providing a start and a stop string separated by a colon. For example, we can select all of the rows within a 4-day window. The Pandas toDatetime function can convert strings in ISO 8601 format into Pandas datetime objects. For example, here's a few entries from the evening of February 11th. We sometimes need to reindex a series or a data frame. Reindexing involves providing a new index and matching data as required. Here, the reindex method returns a new data frame with the 4 rows corresponding to the times in the evening to 11. 2 matching entries from sales are found at 2000 and 2300 from the evening of February 11th. The remaining times in evening to 11, namely 2100 and 2200, are filled with NaN by default. When using reindex with missing entries, we can override the default behavior for filling with NaN. Using the argument method =ffill, which means forward fill, the empty entries are filled using the nearest preceding non-null entry in each column. We can also specify method =bfill for backward fill, the opposite of forward fill. Which is better depends on the context of your data processing task, so Pandas gives us some flexibility. Now it's your turn to practice working with datetimes and Pandas series and data frames.